everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on mole ratios, how to use a balanced chemical equation to figure out the ratio of any two substances in your equation. Alright, so here we have a balanced equation for Fe plus 3O2 yields to Fe2O3. So I can come up with a mole ratio between any two of these three substances. These coefficients represent the number of moles of each substance I need in order to make the reaction happen. So I can have a mole ratio between Fe and O2. I can say that 4 moles Fe are equal to 3 moles O2. Or I can go vice versa, 3 moles O2 over 4 moles Fe, etc., etc. All right, so I can do that with any two substances, and so I can use this to convert between substances. So if I start with moles of O2 and I want to know how many moles of Fe I need for a given number of moles of O2, I can use this mole ratio. Moles of O2 cancel with moles of O2, and I'm left with moles of Fe. So that's the gist of how we use our mole ratio. So let's do some examples. So this says, what is the ratio of O2 to Fe2O3 in the reaction shown below? So here I'm given O2 to Fe2O3. So there's 3 moles of O2 and there's 2 moles of Fe2O3. All right, and since we're only looking for the mole ratio, that's all that I have to do. All right, so how do we apply this? Let's do a couple of those. So this is how many moles of O2 are required to produce 3.75 moles of Fe2O3. Okay, so we approach this in the same way that we approach any other problem that involves conversions. We start with what we're given, which is 3.75 moles of Fe2O3. And I'm trying to find moles of O2. All right, so I'm not changing units, I'm only changing substances, so I'm going moles Fe2O3 to moles of O2. Anytime I change substances, I need a mole ratio. So I'm going to start with what I'm given, 3.75 moles Fe2O3. All right, and then whatever I'm starting with, I put in the denominator to get that to cancel. So moles of Fe2O3 will go on the bottom. And then I need to figure out what number to put with my moles. So I go back to my equation, and there are 2 Fe2O3s, so that means that there's 2 moles of Fe2O3. On top, I put O2 because that's what I'm looking for, so that'll be moles of O2. And again, I go to my equation, and I see that the coefficient in front of the O is 3, so I have 3 moles of O2. So we get moles of Fe2O3 cancel with moles of Fe2O3, and I am left behind with moles of O2. All right, so this would be 3.75 times 3 divided by 2 moles of O2. All right, so when we do this math, we get 5.625 moles of O2. And then in our last step, we need to do significant figures. So this is going to be 3 sig figs in my problem. So 3 sig figs would be 5.62, and that 5 means we round up. So 5.63 moles of O2. All right, and so to have a correct final answer, I need the correct number, I need the correct sig figs, I need the correct unit, and I need the correct substance. Okay, let's do a couple more. This is how many moles of Fe2O3 can be produced by reacting 2.5 moles of Fe. So again, we start off with what we're given. We are given 2.5 moles Fe, and I'm trying to find here moles of Fe2O3. So then we set up our problem. Start with 2.5 moles Fe. So if we're starting with moles Fe will go in the denominator. I check my equation and I see that there is a 4 in front of the Fe, so that'll be 4 moles of Fe. I'm solving for moles of Fe2O3. So moles Fe2O3 will go on top, and I have 2 moles Fe2O3 from my equation. So I get 2.5 times 2 divided by 4, and I get 1.25 moles Fe2O3. Now I check my sig figs. I have 2 sig figs here, so this is going to be 1.3 moles Fe2O3. Okay? This says how many moles Fe are required to react with 11.8 moles of O2. So here I am given 11.8 moles O2, and I'm looking for moles Fe. All right, so I start with 11.8 moles O2 times, starting with moles of O2, so moles of O2 go in the denominator. There's a 3 in front of my O2, so this would be 3 moles O2. And then I'm solving for moles of Fe, and there's a 4 in front of the Fe, so 4 moles Fe would go on top. All right, so moles O2 cancel with moles O2, and I am left with the unit of moles Fe. So 11.8 times 4 divided by 3 gives me 15.733 moles Fe. Check our sig figs. So I have 3 sig figs in my problem, so 1, 2, 3 sig figs in my answer. Gives me 15.7 moles Fe. All right, let's do a couple more. So here we have a different equation. We need to balance this equation first. So here I start with what I have most. I have 3 S's here and 1 here, so I'll put a 3 there. I have 2 ALs, so I'll put a 2 here. And 3 times 2 gives me 6 Na, so I'll put a 6 here, which means that there's a 1 there. If you're still having trouble balancing equations, you should go back and watch the balancing equations video. So now we can attack this problem. So we are given here 46.4 moles of Al2S3, and I'm trying to find moles of Na2S. We start with what I'm given, 46.4 moles Al2S3. Starting with moles Al2S3, so moles Al2S3 goes on the bottom. There's a 1 here, so this would be 1 mole Al2S3. And then I'm solving for moles of Na2S. So Na2S is here, so this would be 3 moles Na2S according to my balanced equation. All right, so moles Al2S3 cancel with moles, and I'm left with moles of Na2S. 46.4 times 3 gives me 139.2 moles Na2S. For my significant figures, this has 3 sig figs, so 1, 2, 3. This would just be 139 moles of Na2S. Here we have the same equation. It's already balanced here. Since we balanced it once, we don't need to keep balancing it. How many moles of Al can be made from 4.32 moles Na? So I am given here 4.32 moles Na, and I am trying to find moles of Al. Right, so we start with 4.32 moles Na. Since we're starting with moles Na, that goes in the denominator. There's a 6 with the Na, so I put 6 moles Na. And then I'm solving for moles of Al, so according to my equation, I have 2 moles Al. Moles Na cancel with moles Na, and I am left with moles of Al. 4.32 times 2 divided by 6 gives me 1.44 moles of Al. Significant figures, I have 3 sig figs, and I already have 3 sig figs. So I don't have to do anything. Yay! Next we have how many moles of Al2S3 can react with 6.4 moles of Al. So here I am given 6.4 moles of Al, and I'm trying to find moles of Al2S3. Right, so I start with 6.4 moles Al, and I'm starting with moles of Al, so moles of Al go on the bottom, so it's going to be 2 moles of Al, and I am converting 2 moles of Al2S3. There's no coefficient here, which means that I have 1. So 1 mole Al2S3. Moles of Al cancel with moles of Al, and I'm left with moles of Al2S3. And 6.4 divided by 2 is 3.2 moles of Al2S3. So my sig figs here, I have 2, and my answer already has 2 sig figs again. Great. All right, let's do one more. How many moles of Na are needed to make 7.391 moles of Na2S? All right, so I'm given 7.391 moles Na2S, and I'm trying to find moles of Na. All right, so I start with 7.391 moles Na2S times moles of Na2S are what I'm starting with, so moles of Na2S are going to go on the bottom, and according to my equation, I have 3 moles Na2S, and then moles of Na are what I am finding. So moles of Na2S cancel with moles of Na2S, and I'm left with moles of Na. 7.391 times 6 divided by 3 gives me 14.782 moles Na. Check my sig figs here. I have 1, 2, 3, 4 significant figures. 1, 2, 3, 4 significant figures. So this will be 14.78 moles of Na. That is the mole ratio. This has been another episode of Chemistry with Wikipedia, Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.